My name is Omkar Vurti. I am your physics teacher. Guys, are you uncertain with the Heisenburg uncertainty principle? Don't worry guys. Today in this video, we about to discuss about the Heisenburg uncertainty principle. What is our topic? Heisenburg uncertainty principle. Guys, actually Niels Bohr said that electron revolves the nucleus in a particular atom with a certain radius. What is Niels Bohr said? Electron revolves around the nucleus with a in a atom with a certain radius. This is a nucleus. This is electron. This electron revolves around the nucleus in a particular atom or shell with a certain radius. Who said that? Bohr said that. So, we determine the position of electron and velocity of electron we determine with the help of radius. Where is the electron position? How much the velocity of electron? We determine with the help of Niels Bohr theory. But that electron moves as a wave. Electron moves as a wave. Guys, we had discussed about the de Broglie hypothesis before the video. If you want to watch that video, go to the first video. Better to understand, to watch about the de Broglie hypothesis. Actually, de Broglie said that duality of particle. He said electron moves as a wave. Duality of particle. Particle possesses both particle nature and wave nature, he said. But Heisenberg said that these two laws are wrong. Ruled out these two laws. He said that it is impossible to determine the both position of electron and momentum of electron simultaneously and accurately. Delta x into delta p greater than or equal h by 4 pi. He said. He proposed. Just I will write.
It is impossible to determine both position of electron and momentum of electron simultaneously and accurately.
This is what Heisenberg uncertainty principle. It is impossible to determine both position of electron and momentum of electron simultaneously and accurately. Delta x into delta p greater than or equal to h by 4 pi. Guys, I have small doubt. How can we see the objects? How can we see this marker? Yes, light enable to allow to see the objects. Light allows to see the object. Actually, this is the object. Light strike this object. This object reflects the light into our eye. so that we see the objects. If light strike this marker reflects the light into our eyes so that we see this marker. But electron, this wavelength of visible spectrum strike the electron can't reflect it because electron size is small than the wavelength of visible spectrum. Electron size is we can't determine, but wavelength of visible spectrum 300 according to visible spectrum 350 nanometers to 750 nanometers. According to other sources 400 nanometers to 700 nanometers. Both were correct. Both were correct. What happened? Size of the electron is very less compared to wavelength of visible spectrum. That's why this wavelength skipped to electron. This wavelength travels through the electron. Electron can't be reflected because that size is very less compared to the wavelength of visible spectrum. So we can't determine the position of the electron. We determine not accurately with some error. We can say probability. Electron position, the electron may be there, but we can't exactly say the exact position. And wavelength inversely proportional to energy. If give the low wavelength, its energy is very high. Do you know the visible spectrum? VIBGR. In the VIBGR, violet, we can't see the violet and indigo because these wavelengths are very less. So energy is very high. So high energy we can't observe with our naked eyes. So we can't see the violet and indigo because this wavelength is very low. High energy is very high. According to red, this wavelength is very high. This energy is very low. Okay, guys, do you know? Actually, we thought that red is very dangerous color. Red used to dangerous symbols. So in our mind, when the red is, we listen the red, oh, it's very dangerous. But do you know, according to VIBGR, violet and indigo is very dangerous because that energy is very high. We can't see with our naked eyes. Because that energy is very high, red energy is very low. Okay? So, wavelength inversely proportional to the energy. If the wavelength is high, energy is low. If the wavelength is low, energy is high. So, if give the low wavelength, the electron position will be changed. Electron, if give the low wavelength, the energy is very high. So, electron can't bear the energy. That's why electron position will be changed. If you give the high wavelength, we can't determine the electron size. If you give the low wavelength, energy is high, that's why we can't determine the momentum of electron. So, Heisenberg, as per the Heisenberg, it is impossible to determine the it is impossible to determine the both position of electron and momentum of an electron simultaneously and accurately. We determine with some error. We can say that some probability. Yeah, electron is maybe it there. But we can't say exactly. We can say with some error. Okay? And delta x into delta p, wait guys, delta x into delta p greater than or equal h by 4 pi. We know what is the meaning of p. P nothing but momentum. What is the momentum? Mass into velocity. Before the class we had discussed. Momentum means mass into velocity. So delta x into delta m into v greater than or equal h by 4 pi. So mass is constant. Mass doesn't depend on any parameter. That's why mass is constant. Before the class we discussed what is the difference between the mass and weight. So we had said mass is constant. Mass doesn't depend on any parameter. So delta x into m into delta v greater than or equal h by 4 pi. Okay? Delta x into delta v greater than or equal h by 4 pi into mass. Okay? What we will understand? Delta x into delta v inversely proportional to the 1 by mass. Delta x into delta v, what? Uncertainties. These are uncertainties. These are uncertainties. So, if the high mass of the object, low uncertainties is there. If low mass of object, high uncertainties is there. Because delta x into delta v, these uncertainties inversely proportional to the mass of the object. Inversely proportional to the mass. So, big mass object has the low uncertainty. Small of object has the big uncertainty. Live example. If you were jogging on the road, we determine your momentum, but also we determine your position with some error, but that is negligible. In the macroscopic objects, we determine the position and momentum, but that uncertainty is negligible. Why? Because you first 1 second you were jogging 10 meter per second. After that your position, after second your position will be changed. After the third second your position is changed. Your momentum we calculate with the help of speed gun, and your position might be here or might be here. This is the very low error, very less error. So your position is determined with some error, but that is uncertain, that is negligible uncertainty. Okay, could you understand? Yes. So next, delta x into delta v greater than or equal h by 4 pi into m. Okay. Next, two conditions. First condition is delta x is equal 0. Delta x is what? Uncertainty of position with some error. Uncertainty of position. Okay. Delta x into delta v greater than or equal h by 4 pi. Okay. 4 pi into m. Okay. Delta v greater than or equal h by 4 pi m into delta x. Delta x is equal to 0. So delta v greater than or equal h into 4 pi m into 0. What remains? Delta v greater than or equal to infinity. Infinity. So momentum is infinity. The velocity is infinity. So we can't determine if delta x is equal to 0, delta v we can't determine. And delta v is equal to 0. Delta v is equal to what? Uncertainty of velocity. So delta x into delta v greater than or equal h by 4 pi m. So delta x into greater than or equal into delta x. Sorry, delta v. So delta v is equal to 0. So delta v is equal to 0, it is infinite. Okay. This is the Heisenburg uncertainty principle. What is Heisenberg said? It is impossible to determine both the position of electron and momentum of electron simultaneously and accurately. We determine the position of electron and momentum of electron with some error. We can't say exact position. We can say the probability. Delta x into delta p greater than or equal h by 4 pi. Same the way delta e into delta t greater than or equal h by 4 pi. Delta e into delta t greater than or equal h by 4 pi. He said. This is the Heisenberg uncertainty principle.